Yes.
Very good. Great. Hey, first of all, I wanted to start with thanking Ger for the kind invitation to give my perspective or our perspective on digitalization. And I have to admit, it is a little bit of a clickbait title. Ger was already alluding to that, but the title is, of course, Why Digitalization Will Kill Your Company Too. And even though it's a bit of a clickbait title, I think that there is something to it, because in many presentations, which I used to do a lot of, but then preferably in person, I often started my seminars or presentations with the question of all the companies that were on the Fortune 500 list in 2000, how many of those companies were still on the list in 2014? And what it turns out is that of all the companies that were on the Fortune 500 in 2000, in 2014, more than half of the companies were basically gone from that list. And there's a researcher by the name of Jim Collins. For any of you that have had MBA or business ambitions, have probably read his book, Built to Last. And what he has done is he has studied how long do companies stay on the Fortune 500. And it used to be very, very long. It used to be more than 50 years. And then in the 80s, it was down to 30 years. In the 90s, it was down to, I think, or the early 2000s, it was down to 15. And the most recent research that I saw is that companies on average now only last 10 years on the Fortune 500. And that time period is actually still decreasing. Why does this happen? Well, the main reason why this happens is because companies fail to innovate and build new core capabilities. I mean, they do not respond fast enough and proactively enough and effectively enough against the changes that are happening in the world around them. And if we look at this today, we can really see that it is digitalization that is the key disruptor for companies that are basically pushed out of business, or they're basically pushed from their pedestal as the leaders in their respective industries. And I think that that's a trend that will continue for a good while to come. So just to be clear on definitions, this is the Gartner definition of digitalization. It's the use of digital technologies to change a business model and provide new revenue and value producing opportunities. It is the process of moving to a digital business, which I think is a relevant title. If you go to Boston Consulting Group, they typically talk in terms of the strategic building blocks of digital transformation. And what you can see here is that they've organized this in a number of different areas. But if you look at the bottom light green row, you can see that some of the things that many of us have been working on for quite some time, agile organization, system and technology platforms, analytics and data integration, and a digital partner ecosystem are very central in this. And of course, those are considered to be digital capabilities. And the fun thing is that this is not just something that touches only R&D. This is actually something that touches each and every function in the company, which is something that many companies struggle with. If I then get the question, which I do get a lot, what makes a company digital? And I'm going quite quick because I want to leave some time for questions at the end, and this is only half an hour. But I mean, typically what I get when I ask people what makes a company digital or what makes a digital company, it's things like, do we have email or chatbots or video conferencing or social media? Does that make me digital? And obviously, I think all of us in this call know that that is not what makes a company digital. We believe that there are a set of characteristics of companies that make them digital. So the first is data-driven decision-making. Rather than making decisions based on opinions or experience or other kinds of things, we make decisions based on data. The second that we see digital companies do is experimentation. You cannot know many things around what works for customers, what works in an ecosystem, are fundamentally unknowable, and the only way you can find out about them is by experimenting. A/B testing is a very good example of that. Yesterday, one of my PhD students defended his thesis around A/B testing. But I mean, relentless experimentation is, I believe, critical. The third is short feedback cycles. From the moment you make a decision to the point that you get feedback on that decision, you want to have as short feedback cycles as possible. Fourth, decision making is pushed down in the organization. If you believe in data-driven decision making, then you should allow the people that are closest to the data to actually make decisions. So rather than using the Christmas tree of traditional hierarchical organizations to push decisions up in the hierarchy, now what you try to do is you try to push decisions as far down in the organization as you can and make decisions there. Strategic data collection, we're going to come back to that a little bit. A unified data warehouse, pervasive use of AI and automation, and also new job descriptions. In the interest of time, I'm not going to spend too much time on this, but I think it's important these are some of the characteristics that we feel make a company digital. We work a lot, and I'll introduce Software Center in a little bit, with companies that have started in the mechanical engineering space. That is what made them successful, and that is what differentiated them in the past. So you then got companies that started off with mechanics, and then in the 80s and 90s, they started to add electronics. In the 90s and 2000s, they started to add increasingly much software to their products. And over the last years, data and artificial intelligence, big data and artificial intelligence have been added as the key technologies. If we talk about digitalization, then what we mean is the three key digital technologies and their implications. And the three key technologies are, of course, software, data, and artificial intelligence. What we see is that when you look at this, and there's a reference to a paper at the bottom of this, then there is a shift happening. The companies that used to be very good at mechanical engineering, they do not drop the mechanical engineering. The problem is this, that the mechanics parts and the electronics parts of the products increasingly become commodity, and the differentiation increasingly comes out of software, data, and AI. And if you go to computer gaming, for those of you that are interested in that space, already the software in many gaming companies is considered to be commodity, and the real differentiation for gaming companies tends to be in the data and artificial intelligence. There are a few implications that happen when you go through this transformation. So when the differentiation shifts to digital technologies, and the first is that your business model tends to change. So rather than having typically a transactional model, I buy a car from you, I drive the car for 5 years, and then I come back and I buy a new car from you. They're very transactional in the way that I interact with my customers. When digital technologies become the predominant differentiation in the offerings that you give to your customers, you tend to move to more continuous business models, such as subscription or other forms. But typically, you have a continuous relationship with your customer, which is then also enabled by DevOps and DataOps and MLOps, etc. The other is that with every technology that you add, you bring in new partners into your ecosystem. So when you add data, you need new people to help you build the competencies and capabilities and deal with the onslaught of data that you're typically dealing with. When you start to work with AI, again, you typically evolve your ecosystem and add new partners. And then the final part, I was already referring to this, is that we are introducing new ways of working. So I think many people have heard the term DevOps, but also the term DataOps around how you work with data, and MLOps, which is one of the other topics where you talk about machine learning and operations. All those technologies and new ways of having implications on new ways of working that we all need to take care of when we are working in a digitalization context. One of the key things that for the software center companies that I'll introduce in a minute is still something they're trying to wrap their heads around, is that traditional value delivery to customers used to have this transactional model where I buy the car, I drive the car is the best it will ever be when I drive it off the lot of the dealer, and then it gets a little bit worse every day until it is such an annoying piece of junk that I go and buy my next car. And the next car is a little bit better than the previous one, but basically I drive the thing until I'm sick and tired of that one, and then I buy the next one. What we now see, and many of the companies in Software Center are working on this, is that we're basically looking for forms of continuous value delivery to customers. And I think Tesla is a good example here. The idea basically is that the moment you get the product, it is maybe very, very good, but it is the worst it will be throughout its entire life. And what you will then see is, of course, we will have continuous software deployment. So if you look at Tesla, every 2 months or something, they tend to update the software in the car. But what we can also see is that companies are starting to think about how can I upgrade the electronics in the car. Tesla offered about, I think 2 years ago, an upgrade for the electronics in their vehicles, so that every Tesla going back to 2012 would basically be able to get the electronics in the vehicle that would allow it to get to full autonomous drive on the highway. And you can also start to think about replacing mechanics. I think that that's an important way to think about it, because then it isn't just the software that goes through the DevOps cycles and everything else is basically static and slowly degrading. Now, the idea is that the whole system is evolving and providing more value to the customer all the time. And we're going to come back to that in one of the upcoming slides. I'm talking very quickly, but at the end we can take some questions. So the points I'm trying to make, and this is what we'll be talking about in the rest of the talk, digitalization is disrupting industry and society to an extent that we've only seen the early beginnings of. I mean, I'm starting to become a little bit gray-haired, so I feel that we've come a long way since the 80s. If I look at what is happening in computer science. But to be honest, I think we've barely started to scratch the surface. In order to be successful as a digital company, I believe, or we believe based on our research, that companies need to be world-class in software, specifically continuous deployment to continuously deliver value to customers, data to increase the quality of decision-making, because it allows you to make much more informed decisions than opinion-based or experience-based decisions. And then finally, artificial intelligence, because in the areas where it is applicable, it tends to lead to superior solutions to almost everything. I even have one company that is replacing traditional PID controllers, for those of you that are a little bit more on the control theory side, with machine learning models that basically optimize over traditional theoretical PID controllers, because they take into account the things that where the real world system is not following the theory that is behind the PID controller. And then finally, to transform to become a digital company requires you to adopt a digital business operating system, which basically talks about these notions that I discussed earlier. We're not going to talk so much about that in this talk, but if you want to learn more, I happily share some of the thoughts. Very quickly about who I am and where I come from, so you have an idea. I think I saw several names in the list that know me from earlier, but I am a professor at Chalmers, and I also have an appointment at the Technical University Eindhoven. I am director of Software Center that I will introduce in the next slides. I run a small consultancy. I also am on a number of boards. Company boards ranging from relatively small ones, companies of around 25 people, to Iver here in Sweden, which is around 1,400 people. I do angel investing, so if any of you are interested in starting a company, don't hesitate to reach out to me. And I do not only have worked in academia, I actually spent about half of my career in industry working for a Finnish company called Nokia that you may remember from the mobile phones. And for a US company in Silicon Valley called Intuit. I lived in Silicon Valley for several years, where I worked as in both cases in vice president roles. So that's my background. If we talk about Software Center today is 17 companies and 5 universities with the explicit mission of significantly improving the digitalization capability of the European software-intensive industry. And we've been looking to add Norway and some Norwegian companies and universities to this, but we haven't managed to accomplish that yet. That is still a work in progress. But what we have now is German companies like Siemens and Bosch, Finnish companies like Wärtsilä, Swedish companies like Scania and Ericsson and the Volvos, and SEFT and others, Zenseact, for instance, around autonomous drive. We have Danish companies like Grundfos and Dive. So this is what we do. And we do research on continuous delivery and architecture and metrics and custom data and ecosystems and AI engineering. Again, this is not the purpose of the talk, but it gives you a bit of a feel for what is this, where is the content of this talk coming from. And we do not only talk to companies that started their lives as metal bending companies. We also frequently interact with online companies or companies that were quote unquote born digital. Booking is one example, originally a Dutch startup. Spotify, all of you know. Rovio is the company behind Angry Birds King. It's a company behind Candy Crush. Klarna and Sync is also well established in Norway, allows you to extend credit for people that want to buy things online. And then, of course, Microsoft, you all know, several of our PhD students have visited Microsoft as well as ourselves. And one of our former PhD students is now working in the data science team in Redmond in the US with Microsoft. So that's the background. I'm going to share a little bit around how we think about moving towards a digital business operating system. And this is a bit of a complex model that I will spend a minute on just to give you a feel for how we're reasoning around this. The paper reference is in the slide if you're interested. But in work that I did together with Helena Holmström-Olsen, the way we generalized a multi-company case study looking into this is basically identifying 4 dimensions of evolution that we see companies go through when they move from being a traditional company to aiming to become digital companies. And I don't want to spend too much time on this, but if you look at the business model dimension, the second one from the bottom, companies typically start with product sales and very little service revenue. The next step is that for specific customer segments, or maybe even for their entire customer base, they offer their product as a service. Then the next step is that the company starts to offer complementary services around their products. For instance, in the case of AB Volvo, they offer advising services for truck drivers on where to fuel and where to find safe resting areas, as well as services for fleet owners to help them manage their trucks. The one after that, the 4th level, is where I basically base my business models on how well I accomplish and improve the KPIs that my customer cares about. So for instance, in the case of AB Volvo, no customer of theirs actually wants to own a truck, but they are typically in the logistics business, and what they do want is they want to have on-time delivery. So one business model is where you get paid based on the number of on-time deliveries. We have another company in the software center that sells factory equipment, and basically they are now starting to offer a factory. After 1 year, they do a baseline of the productivity of the factory, and then they guarantee 5% productivity improvement for that factory for the coming 10 years after the first year of baselining. So those are the kinds of business models that we are starting to see, where companies don't sell a product, but they basically get paid based on how they improve the KPIs that their customers care about. The last part is where you have a multi-sided ecosystem, where you basically collect a lot of data from your primary customer base, and then you repackage and sell that data to a secondary customer base. And what we see happen there is, of course, in the online world, we see this a lot around Amazon and customers and sellers, but we see this now starting to appear also in different areas. In passenger transportation, for instance, there's a lot happening around that kind of reasoning. There is a data exploitation dimension. Again, I'm not going to talk about that through that because I'm running out of time. There's an AI dimension, there's a product upgrade dimension. I want to briefly go through what I believe are the 3 main areas. First is software, as I already mentioned. Here we see companies in a very predictable pattern move, and we've studied dozens of companies, but companies move from agile to focusing on continuous integration and test, to working towards continuous deployment, and then starting to use R&D as an innovation system, where you basically have a deployment in the field, you have X customers, and then you can start to use A/B testing and other kinds of approaches in order to verify in the field what you're actually doing. That brings me to the data side. One of the slides that keeps blowing me away is Standish Group study of about 2 decades ago, where they showed that in a typical system, somewhere between half and 2/3 of all the features in the system are never or hardly ever used. Typically, when I enter a company as a consultant, I tell them that at least half of your R&D effort is waste. You just don't know which half. I can help. Yeah, that's basically the thinking. This is already 20 years old, so we also did our own study a few years ago where we looked into another company in the Gothenburg region where we actually saw exactly the same pattern. What happened was that some service starts, so that's the number of times a feature is actually being used, are used all the time. Some features are used occasionally, and many features are hardly ever, if ever, used. Now, I fully understand that not all features are intended to be used. My car, for instance, has an airbag feature, which I hope will never be used. But still, I mean, this gives an indication of features that were intended to be used are actually not used in practice. We developed something called the Hypex model as an answer to that, where we basically say, I pick a feature out of the feature backlog, I focus on the expected behavior. I try to specify, if I build this feature, what measurable difference or delta will I see in either the user behavior or in the system behavior? And then rather than building the whole thing in the kitchen sink and make it all gold-plated from the start, I only implement the first 10 or 15% of that feature that I believe gives the largest amount of value. And because I have DevOps in place, I can get it out in the field, and then I can start to measure what happens actually in practice. Of course, I've baselined before, and then there are a number of different outcomes that you can focus on. But one of the things that this allows you to do is to basically abandon features that do not have any measurable impact on the system. So you do not invest in features that do not even develop or have any value from the beginning, not even to mention over time. You can also stop developing a feature, even if it gives some value, but it plateaus after you've implemented a certain amount of the functionality. So we think that this is a quite helpful model that becomes relevant once you adopt DevOps. Of course, one of the techniques that we often talk about is A/B testing. I'm pretty sure that many of you are aware of this, but this is one of the examples that one of our PhD students came up with when he spent time at Microsoft. So this is in the Bing search engine where basically there is a control A, there is prices shown, but manual ordering of the games in B, and then there is the prices are shown, and there is automatic ordering in the case of C. And we have value hypothesis. We want to increase the engagement with the Stripe, and we don't want to see a decrease in purchase. And then you can basically run that over your customers. And then it turns out that treatment B decreased engagement, but the purchases were kept constant. Treatment C increased engagement and purchases made. And many people tend to think, yeah, this is only something that is now happening in the online world. No, also companies like Volvo Cars and Ericsson are now running A/B experiments in their systems. So this is becoming real in the embedded systems world as well. And I think something that is good to be aware of. I want to spend my last minutes talking a little bit about AI. We've defined something called the holistic DevOps framework, where we say that the software development in the future will have 3 different categories of development. We will have requirements-driven development. We will have what we call outcome or data-driven development. That's where you apply A/B testing in order to figure out how do I maximize conversion, or how do I improve fuel efficiency, or how do I improve throughput in a telecom network, and give teams basically the opportunity to test different hypotheses using A/B testing. And then finally, A/B or AI-driven development, where I have large data sets I typically labeled. I train machine learning models, but all these components, the result of all these 3 different types of development, end up in the same systems, are all subject to DevOps or periodic updates, and they are all collecting behavioral data in order to make sure what happens. Our experience is that many companies are really struggling. Everyone has their experimental prototyping ongoing. That's not the issue. What we see that is the issue is that companies have difficulty going from experimentation and prototyping to actual real-world deployment. We have here a bit of a maturity model where you can say that we move from prototyping to non-critical deployment, critical deployment, cascading deployment, where you have multiple models feeding into each other, and then finally autonomous models where they basically monitor their own behavior, trigger their own retraining, to give warnings when they are starting to operate outside of their bounds, etc., etc. We call this AI engineering, and the reason that we talk so much about AI engineering is because, and this is not us, there's actually a much older paper, this is a paper by people from Google, who talk about the hidden technical debt in machine learning systems. What you see is the machine learning model is the little black box in the middle. And what the authors of this paper indicate is that in order to make the little black box in the middle work, all the other boxes are required in order to make it work. And many people focus only on the black box and not on everything around this. Actually, right after this meeting, I have a meeting with one of my PhD students, because one of the things that we're looking at is into data pipelines and how do you get reliable data pipelines in place, which is actually surprisingly difficult in many companies. Yeah, so if you talk about the 4 phases of AI, assemble the data set, create a model, train and evaluate, and then deploy, and then of course this goes into circles, everyone and their brother is talking about creating models and training and evaluating. But what we see where the effort goes is actually in getting high quality data. High quality data is actually really hard to assemble, especially as a stream, not just as a data set, but as a data stream, and getting it deployed in a production quality environment. One of the things that we've done, I should have added a reference, but if you go to ArcSIF and look for me or on my Google Scholar profile, you can find the paper. Together with Ivica and Kovic and Helena Holmström-Olsen, we defined with the 3 of us a AI engineering research agenda, where we basically said the 4 phases: data, create a model, train, evaluate, and deploy. And then we basically identified what are the architectural challenges, the development challenges, process challenges. And we also looked at some of the domain-specific AI engineering challenges. And what we've done over the last years is basically assembled a team that looks into different topics. So David, the guy who graduated yesterday, looks into autonomously improving systems. We have Yuchu, who's looking into A/B testing of models. He works at Volvo Cars. Iris at Siemens is looking into architectural challenges around data. Aishwarya, the person I'm meeting in 3 minutes, is looking into data pipelines, versioning, and dependency management. We have Lucy, a postdoc who left recently, who's looking into monitoring and logging. We have Theodore looking into automatic labeling. Hugo into heterogeneous hardware. He also recently left because he finished his PhD. Menu is looking into design methods and processes. And then finally, Hong-Yi looks into federated learning and more recently also into reinforcement learning, which I think is quite an interesting topic. 3 minutes and I've reached conclusion. So we will have 10 seconds for questions again. I'm not sure if any of you recognize this gentleman, but this is George Colony, CEO of Forrester Research. And he already quite a few years ago made the claim that in the future, all companies will be software companies. And I think he got it almost right. I claim that in the future, all companies will be digital companies, companies that are world-class at software and data and AI. And the interesting thing is, if you look at banks these days, the whole fintech industry, if you look at H&M and Zara, what makes those companies successful? It is not the offices, it is not the stores, it is their ability to use digital technologies to find forms of differentiation in their industry that are not accomplishable in any other way. I think that is important to understand. A bank is basically a software house with a few offices connected to it. Fashion companies are the same. It's basically every industry is digitalizing. So just to repeat the things that you heard from me around 20 minutes ago, digitalization is kind of sort of a big thing. In order to be good at this and to survive, you need to be really good at software, data, and AI. And you actually need to adopt what we call a digital business operating system in order to be successful. If you thought this was interesting, I have a few books. The one on the left is something I signed the IP rights away to CRC Press. But the 3 on the right, I can happily send to you in PDF format if you're interested. They're shorter books capturing some of the aspects of the things that I was discussing earlier. And with that, Ger, I would like to thank you all with a minute to spare, I think, for the attention. And I hope I'm happy to answer any questions if anyone has any of those. So thank you very much for your attention. I appreciate the invitation and the opportunity to present briefly what some of the things that we're doing in this space. So thank you.
Thank you, Jan, for a very interesting and compact talk. Any questions in the audience? I think we will do it very simple. The first one to raise a hand.
Total silence.
You have 2 seconds or I have a question. Okay, so I find it very interesting, this focus on making the product development data-driven. But what we also see is that the organizations behind these technologies are also transforming in how they work, how people collaborate inside organizations and between. And I think though that's also a transformation that could be data-driven.
Yeah.
Do you have any experience on clients that are using data or trying to be data-driven in how they develop as an organization?
Okay. Yeah, so it depends a little bit on how you describe develop. But if you go to companies like Booking, Skyscanner, Microsoft, and others, we traditionally had a model where we were organizing in such a way that we had somewhere product managers, and somewhere we had architects, and somewhere we had developers, and somewhere we had people that understood the customer, etc. The most digital and most effective digital companies I know, they tend to operate in cross-functional teams, where the team itself has all the skills it needs to successfully deliver on what it needs to do. Those teams are typically quantitatively managed. Yeah, so if you work for Booking, you will never see a requirement in your life. Yeah, I personally think requirements engineering is highly overrated, but that's a different story. That's a different talk. Yeah, but you will not see a requirement in your life. What will happen is that people will say, you and your team are responsible for this part of the website. Conversion currently is 3.2%. In the coming quarter, your goal is to get conversion from 3.2 to 3.4%. So you get a much more data-driven way of reasoning and measuring the value that different people are actually offering. So I think that that's one example of how you look at it. If you look at the ecosystem part, and again, this is easily becoming a long answer, what I see is that through SLAs, service level agreements, and other kinds of things, we see that there are ways of quantifying and putting data on interfaces between companies. The problem that I see is that the more companies do that, the more rigid the interfaces between the different companies become, and the harder it becomes to actually innovate and do new things. And I think that that's one of the things that I'm trying to understand better. How do we quantify those kind of relations without getting the rigidity and resistance to change that we see in many business ecosystems? I'll stop here because I can talk for another hour on this.
Yeah, but let's find another opportunity to continue on that thread. It's super interesting. So we are over time. Let's say if we have one more question, that's fine. If not, I would like to thank you again, Jan, for spending time with us, and I'm sure we'll get in touch and continue this discussion in some other format.
Awesome. Hey, Ger, thank you once again for giving me the opportunity to kick off your webinar series. Yeah. I'm honored, and I look forward to meeting with you and many of your colleagues and other people in Norway at some point in the future. Yeah. Take care.
Thank you very much. Thank you very much. And please check out the website, smidig.org, for the rest of the program.
I'll do that, and I'm sure the rest will as well. Thank you, everyone. Take care.
Thank you.
Have a great day.
Bye-bye.
Bye-bye.